The next thing we want to know is where to actually point our glider. In other words, which heading we need to fly in order to correct for the wind. And now that we know the wind is from the east at 20 knots, we can make some calculations with that. And there's a whole bunch of other videos on YouTube about how to use an E6B plotter like this, but I'm just going to show you real quickly the relevant ones we need to make for glider flying or glider cross-country planning. First thing you do is we need to mark the wind velocity under the specific direction that it's flying. So first set the true index to the direction of the wind, 90 degrees, directly from the east is what we're saying it is. Then you simply mark the magnitude as 20 knots. It doesn't matter where you center the point because the distance between these thick black lines is the same everywhere. It's 10 knots for each thick black line. So let's just set the center at 100. I'm trying to hold the camera and do this at the same time. Alright, so there we go. So I just centered it, it doesn't really matter where. And just mark up the velocity. So this is 0. First big black line, that's 10 knots. There's 20 knots right there. So just put a light dot there. And again, this has to be under the actual direction that the wind is coming from. So it does matter where this is pointed to. And the next thing is actually changing true index to true course. So for the first leg, our true course we said was 85 degrees. So a very slight shift, not much. Then what you do, knowing the knowing your airspeed, which we said we're going to fly at 41 knots, we just slide this down. And what's important is that you remember, got to pick this up with both hands here. It's the dot that goes to 41 knots, not the center. It's the dot that gets slitted there. All right, so let me actually just... All right. So there it is. So that's the dot that we just drew in. That's what gets pulled down until it's on the 41 line. Our ground speed would read under the center because gliders are very slow. This wasn't really meant for that. But it doesn't matter. We don't really need ground speed for anything unless you want to know how long it's going to take to get there. For safety, you don't really need to know that as much unless it's getting close to dark or something, or But anyway, we can get our wind correction angle just from the degrees there. In this lower range, those black lines are 10 degrees apart. In the upper range, they're 5. So that looks like a wind correction angle of about 2 degrees. It's on the first thin black line there. And you can just do that for all the different sites. I'll do it for one more so you can see. You don't have to change, when you're changing legs, if the wind is the same everywhere, you don't have to move the dot. You can just re-rotate this to whatever new true course you're flying. In this case, it's 72. You will need to re-slide this because that will shift the position of the dot. So we're going to hold 41 knots. So we just slid that down to 41, and there's our new wind correction angle. It's 9 degrees.